This morning we got Dr. Steve Fraulecker, and he's a senior chemist at Prism Analytical Technology. Sarah's back there. She's the one that's going to talk to you, basically, if you call into the lab. It's one of the few labs that I know of that you can call virtually and get one of the lab technicians or one of the supporting doctors on the phone. So they got phenomenal service. So that's part of my commercial. But Steve basically has got his chemistry degree, BS, from Northern Kentucky University, his PhD in analytical chemistry from Purdue. His thesis work was basically done at Frontier Transform mass on a mass spectrometer. You can tell I was up all night. He's basically studies the phases of ionic molecular reactions. Steve also worked for Prism since 2011. His interests include understanding and correlating volatile organic compounds, and probably microvolatile organic compounds sources, improving the development in new methods for the VOC, for semi-VOCs, and detection, education awareness of VOCs, air testing, and Jason chemistry lecturer at local universities for the past 20 years. And most of you might be familiar with the fact that ASHI Reporter featured him in the Reporter not too long ago. If you don't or didn't see the article, go back in our archives and make sure you bring it up. It was an excellent article. Those of you that are not doing sampling with VOCs and mold and so forth, you're missing the boat. My home inspection business went from doing 100% to my environmentals, which now is 60% of my business. And the way I got there was, everybody knows about continuing education to go to realtors and brokers. Try going and doing continuing education for insurance brokers and agents. They'll give you a lot more business, and it's not pertaining to the home inspection business. Without any further ado, Steve, would you? And please come to the mic for your questions, because this is being recorded.
Okay, thank you very much for that introduction. I'm happy to say that I'm here and my students are taking an exam today while I'm not there. So, I'm here in a different capacity today. As Shannon mentioned, I work at Prism Analytical Technologies Incorporated as an analytical chemist, and we do VOC testing and air testing, and typically that's what I'm here to talk about. I gave a talk yesterday on a Lunch and Learn, but today I'm here in a different capacity. As a scientist, I'm always interested in new areas, and so this is kind of a new area for me to be talking about and to try to help you with, and that's with air filters, air filtration, and those types of processes. And the reason for this is because over the past 6 years, taking your phone calls, I've come to have a lot of questions asked of me of what types of filters are applicable for VOC filtration and other types of filtrations, and effectiveness of ozone generators, etc. So I'm here today to talk and share that knowledge I've discovered over the past 6 years with you. And if you have any questions along the way, feel free to ask. I've updated the slides some, so I'm going to make sure that that ASHI gets a copy of those to put into this time slot to make sure that you have the most up-to-date slides available. So what I'm going to talk about in general is, in order to understand how to filter something, you need to know what it is that you're filtering. So the first thing I'm going to talk about, first part of the talk, will be discussing sources of VOCs, particulates, molds, etc., allergens. And then I'll get into talking about the beginning of thought process of how you would remediate indoor air quality. And then talk about different air purifiers and air purifier technology. Air purifiers with enhanced cleansing technologies such as photocatalytic oxidation. And then finally, just a few words on shock treatment using ozone. We've got a couple of slides for that and general discussion of that more than anything, and then summary and conclusions. So within hopefully 2 hours, you will have an opportunity to understand more about the filtration from what I've gathered to know. I'm not an expert in the area by any means, but again, if you have something to share that would be beneficial to the audience, please do so. I'd be happy to hear those comments. So what encompasses indoor air quality? And indoor air quality is many, many different aspects to it. And the one thing that I'm not going to talk about today is radon remediation. It's a very important area, but that is definitely something handled by somebody who's pertinent in that area. But besides radon, first thing we talk about when you're in a room is, are you comfortable? Is it too hot or is it too humid? And so that's one of the aspects of comfort in an indoor air setting. But then you think about other areas like molds. Are there molds present? Carbon monoxide and carbon dioxide. Typically, carbon monoxide has been under control because of the fact that we monitor for that. But carbon dioxide we less frequently monitor for, and we have some guidelines for CO2 emissions based on ASHRAE recommendations. And then you talk about particulates, and that comes from lifestyle. You have skin cells, etc. Allergens that could be present that could be impacting indoor air quality. And then finally, particulates that could be present from building processes. And then finally, we have the VOCs, which pretty much is what you are breathing in the room on a normal basis without really even thinking about that. So every room has indoor VOCs, including this room here that we're in today. So first of all, let's talk about some air quality basics. Indoor air is definitely contaminated with particulates, allergens, molds, and VOCs. In fact, the EPA indicated that indoor air pollution is one of the top 5 environmental issues and health risks that are present in the current day. And so it's something that we need to take seriously. And so, the more we hear about things like lumber liquidators with formaldehyde issues and where formaldehyde impacts our respiratory system, the more we want to know how we can handle these things and what our levels are. And so it becomes very important. And I think as we go through time here, with some of the assessments that come through, California being our strictest state, they come up with more and more guidelines for different VOCs. And I think there's going to be more and more interest in the future in commercial buildings and in homes for understanding what the VOCs are and how to remove them. So particulate matter, allergens, tobacco smoke, they can all affect occupant health. And then again, we want to be able to have decent comfort levels for the occupants that are here. So we'll find out that source removal is actually the best method to remove VOCs if you can do that. But we'll get into that a little bit later. So when you think about indoor air, and these come from totally my thought process, this baseline VOC business. When you think about building a building or a home, you have the basic foundation, and then you come in with all the materials of construction. And there are LEED guidelines in place for buildings, and some people try to be green by being less than a certain TVOC value and things like that. But when it comes down to it, you end up with a baseline VOC level for that particular building. And then on a daily basis, through our habits as people, whether it be personal care products that we use, hobbies that we perform, we kind of add to that VOC level on a daily basis. And based on ventilation, the VOC levels can come up and come down. And so in general, if you take a 2-hour air sample, you're going to get a snapshot in time of what's present in that room at that point in time. So that baseline level, this room has a baseline level. And the minute we walked into this room, all of our personal care products that we have on added to that baseline, if that makes any sense. So in general, we are what we breathe, and or we breathe what we are, whatever. And that's one of the things that I look at as the baseline. And then how do we exacerbate that as individuals to do that? So indoor air quality can be instantly impacted through the use of personal care products, cleaning products, new construction, repair products, etc. So IAQ testing yields a snapshot in time. And the reason for these changes can be that there have been more and more VOC issues, and a lot of it has to do with the fact that we have more airtight buildings that have been built, less leakage, and so when you have less leakage, you've bottled up what's inside as well. There are newer synthetic materials that may be off-gassing different VOCs. There's an article, I believe the author's name was Weschler. He talked about VOCs over the last 50 years, and starting about 30 years ago is when you started having all these VOCs associated with plastic materials being present. And we spend a lot more time indoors these days, especially younger people. When I was in grade school and high school, I was outside all the time, but now it's the video generation and everybody stays indoors, and it's safer to be indoors in many areas. And so we need to be worried about our indoor air quality with regard to that. And finally, there are increases in respiratory conditions. Visits to asthmatic, to allergen doctors are at an all-time high based on our chemical sensitivity to what we're breathing and what we're being impacted by. And this is just to show that newer homes are more energy efficient. We tighten them up, we bottle them up, and older homes actually have fewer VOC issues typically because they're not energy efficient and they allow better release of the VOCs from within. But the newer homes, you keep recirculating the same thing, and it's become more important recently to try to add some fresh air intake, more fresh air intake into the homes to try to dilute some of that VOC presence of the air inside the home. So we are actually more efficiently trapping the VOCs within the newer establishments and the newer buildings. So all of this is setting up the dialogue for why we would want to have filtration, keeping that in mind. Comfort levels, like I said earlier, the outdoor air level is 380 ppm, and the indoor CO2 levels. I know many home inspectors use monitors for this, handheld monitors for CO2, and so once you get above a certain level, you need to really consider like ventilation issues. So I'm not going to speak any more on that. But TVOC is a general indicator, though, that we typically look at for indoor air comfort as well. The green guideline is to have less than 500 nanograms per liter of your TVOC. And then you have individual compounds that are in there. The problem is, for homes especially, there are no TVOC guidelines. We generally try to follow for instance, LEED guidelines, but those are mainly for commercial buildings that are being built. You can have a green home, and they do pretty much use those same kind of standards, but there's really not an actual U.S. standard for your home has to be here. There's no regulation for it whatsoever. So as far as the methods go, there are many methods for getting a TVOC, and I know many people use handheld monitors, and then also there are air testing methods used by different analytical testing method companies. So when you think about the TVOC guidelines, though, the general comfort range, Mojave is a Danish scientist who studied VOCs and indoor air quality. And he established that you're generally comfortable if it's less than 200 nanograms per liter, which is kind of low. So typically, when we think about comfort levels, we typically think of a green building or a green home. You should be comfortable at less than 500. And then, in general, you should be okay between 200 and 3,000 nanograms per liter, but there are some elevated VOCs that could cause you problems. So if you're in that range, and let's say you just had some plastic lined pipe put into your home, well, the tetrahydrofuran THF from the PVC cement is going to be fairly high in your home. That's a respiratory distressor. And so you might have some issues of discomfort based on a new application based on building products. Once you get above 25,000 nanograms per liter, though, you're kind of in a toxic range. Even though OSHA levels are still hundreds of times higher than that, you don't want that kind of a level of TVOC in your home or in your business. So things start becoming very uncomfortable for people. So 300 nanograms per liter can be reasonably achievable, but again, we've found that the average home is about, based on all the different habits we have in personal care products, alcohol, those wipes that you use for hand sanitizing and et cetera, that the typical home, from 8,000 homes, the average is about 1,900 nanograms per liter. And then again, I mentioned the green building being 500 nanograms per liter of what people are trying to achieve, with formaldehyde levels less than 37 nanograms per liter. So what are the sources? Well, for buildings, it's the building materials, it's the wood products used. Paints and coatings are very high. They take a while to decay. There's this misconception that low VOC and no VOC paints don't have VOCs. Well, that's just the official definition by the federal government of a VOC is it's any organic compound that will interact with the outside atmosphere to create products that could be detrimental to the ozone layer and the environment. And so these include things like xylenes and toluene and that kind of thing. And so what paint manufacturers do is they replace those with glycol and glycol ether materials that are lower as far as their vaporization characteristics, but they take a lot longer to off-gas. And they are considered to be VOCs still. They're just not the VOC definition that the federal government uses. So we find that quite a bit. We also have adhesives and mastics and cements that are used in building products and roofing materials. And these can remain for years and slowly off-gas over time. And then we have occupant lifestyle, and then outdoor. Outdoor is not much of a contribution unless you're in an area where there's a lot of spraying that takes place. But we typically see issues with spraying outdoors around your base foundation and then having the fuel carrier coming in through the windows. So it can become a problem. And then you also have VOCs that could come from wildfires, that kind of situation. So as I mentioned earlier, we have baselines, and that baseline then could be elevated also by your lifestyle. You could put in mothballs or moth crystals for pests. And also those are used in bathroom cakes that are used in restrooms and bathrooms within homes. And then you paint and use there are all kinds of coatings that come on new furniture. Kerosene, diesel, and fuel oil. If you have an attached garage and those vessels are there, then those are going to creep into the home as well. So in general, there's just a lot that can come into your home without you even being aware. When you go to the gas station, when you go home, you've just introduced gasoline vapors from your clothing into the indoor air. And especially as a home inspector, if you go take a test, just make sure you haven't come from a gas station first, because you could be contributing to the homeowner's VOC tests with the gasoline vapors from your clothing. So just be very careful about what you carry in. It's kind of like what Jeff May was saying yesterday about, don't look in the attic or the basement first when you're looking for mold, because you're going to get some on your clothing that will then possibly contribute to the indoor environment in the main room. And then finally, these are just, I'm not going to be exhaustively going through this, but this is just a variety of different VOCs that can come from different materials of constructions, from building products that are used. So every time you do a renovation in your home, you're introducing a whole new level of VOCs. And then there's formaldehyde. Formaldehyde comes from any kind of wood. If you send a sample to be analyzed for formaldehyde, you're going to get formaldehyde from it. Doesn't make any difference what kind of wood you have. It's going to produce some level of formaldehyde if you heat it up to, let's say, 50 degrees C. Formaldehyde naturally comes from cellulose degradation, and it's in the wood. It slowly off-gasses over time, and also can off-gas differently in different temperature and humidity conditions. So formaldehyde is always there. But it's even there worse when you have poor materials of construction from other countries, for instance, that use particle board for cabinetry inside. It looks really nice on the outside, and then they use this really cheap particle board on the inside, or oriented strand board, which is known as OSB, and different things like that. So plywood contains formaldehyde, but the outdoor levels for formaldehyde are 5 to 15 nanograms per liter, depending on where you live. In NIOSH, they set a limit of 20 nanograms per liter as being what you should be exposed to. Well, your home infrastructure is going to add more than that to the already outside air of 5 to 15. So we find that in general, that a normal home has an average of about anywhere from 50 to 70 nanograms per liter of formaldehyde already there. And then when you put in flooring that contains wood, adhesives, etc., you're going to add to that. So you need to really be careful about ventilation and other issues. But formaldehyde is one of those VOCs that really does cause a lot of respiratory distress in people, and a severe irritant of the mucous membranes, irritation of the nose, throat, and the eyes. And it is classified as a group 1 carcinogen, so it is something to be concerned about. So, and one other source of VOCs that a lot of people don't think about are vapor intrusion, which comes from contaminated soil due to spillage or from past industries that were in that area that leaked into the ground, and then that's now coming up through people's foundations into the home. So something to always keep in mind. Know the area that you work in, whether or not there are any of these locations where there could be an issue involving soil vapor intrusion. So it's a challenge to everyone, though, and health effects can vary from person to person. Odor thresholds vary from person to person, but it all deals with what we're breathing on the inside. And so, but other than VOCs, we also deal with these other areas I mentioned earlier. And so just briefly, I'm going to touch on particulates, which include dust, dander, and pollen, because we have to worry about how we're going to deal with that with filtration as well. And so what is the concern with particulate matter? It's microscopic, and the fine particulate matter you sometimes hear referred to as PM, okay, particulate matter. And it's the fine material, less than 2.5 microns and smaller, that causes our biggest concern, because those particles can embed deep in your lungs when you breathe, okay? And that's the stuff you really need to worry about. That's not coming back out right away, okay? And then respirable coarse particulate matter is in the range of 2.5 to 10 micrometers, and that gets into your upper respiratory tract, so that can be released eventually. And then the coarse dust is usually in your nose and throat, and you usually cough that out. But I thought I'd put those levels in there in red so you could see the effect on individuals with regard to that. But these microscopic particles lead to allergies, respiratory conditions, cardiovascular conditions, excuse me, and in the case of something like asbestos, it can cause cancer. So we have outdoor indicators, and you can most people refer to a microscopist for looking at particulate matter. And the outdoor indicators include bioaerosols, which include mold, pollen, plant parts, insect parts, and we also worry about infiltrated soil and combustion particles. Whereas indoor indicators are from building materials such as carbonates, silicates, sulfates, skin cells from people, and then fibers, dander, dust, and dander from pets and cats and dogs. And then these are, again, a couple of examples of the, yes. Oh, do you mind using the microphone? I'm sorry. Thank you.
Besides the issue of the dander with the pets, we also have the clumping cat soil and things of that nature. What are the gases off of that from the clumping, or for the fact that you can't smell the cat pan anymore? Is that a concern, or what contribution does that make?
Yeah, urine odor, especially with cat odor, is a really hard thing to identify in a mass spectrometer, for instance, because it doesn't like to go through a GC column very well. So we have an issue with that. But as far as I know we for some reason in our home have our cat litter boxes right by the furnace. So it's kind of ridiculous. But you do get the dust build up. I don't notice the odor as much because I usually try to keep it clean every day. But definitely you have a dust buildup and when I look at that dust, I think to myself, that looks like it's like less than 2.5 micron when it's being emitted. So to me, it's an issue of going through the home if you have it real close to the furnace, especially. These particulate matter could go through. But otherwise, I haven't heard any health issues associated with the cat litter, other than the fact that I know that the dust is there. Have you heard any issues or? Okay, and he replied, no, that's why he was asking. So if anybody else has any further information on that, feel free to share it. please.
Most of those litters are made up out of a clay base,
Okay.
so they don't tend to become as airborne,
Okay.
but not next to the air exchanger, please.
Thanks. All right, thanks, Shannon. And then we have microbial sources of VOC, or not VOCs, but microbial sources. These are single living organisms, viruses, bacteria, molds, and these can travel throughout the air, a lot of times on air particles or particulate matter. And sometimes just by a simple sneeze can carry viruses in a long way. So it's not something to it's something to be aware of as far as microbial. So again, all these will be talked about when we talk about the air filtration processes. And the concern for mold, of course, is potential health effects. And Jeff May yesterday indicated that some molds indoors will cause damage to your materials of construction and others won't. I'm not going to go into details on which will and which won't. I think his slides are available online. And there's no real practical way to eliminate all molds from indoor environment, though, because molds are prevalent outside. Usually they're not as prevalent in the winter and when it's cold, but as Jeff pointed out yesterday, you can grow mold in your refrigerator on food. So molds they still grow in the cold. So you just have to be aware of that. But moisture control is the key. For mold to grow, you need to have a nutrient and temperature in order to do that. Nutrient, moisture, temperature, and that's the way a mold will grow. So if you can control the moisture and then in the temperature, then you're doing well on trying to at least control the mold growth. And there's no official limits for mold or mold spores. For allergens, it affects more than 50 million Americans every year, and it's getting worse. It's an immune system overreaction to certain substances. A lot of people are now chemically reactive, so they're more VOC reactive than they are any other type of allergen. And you can get a chemical sensitivity immediately from some adhesives that will then carry over to other types of VOCs that are similar in nature. It can be a very severe problem with regard to essentially the human condition. And then we have allergens like dust, ragweed, pollen, etc. that we can have present. And again, it's on dust, so if there's dust in the home and that gets swept, through air movement, just gets swept up into the environment, it can be very costly for some people. I mean, you can sit there, I've sat there at a kitchen table before and say, well, there's a really strong sunbeam coming in, and then you just wipe your hand across the table and you can see the particles floating up into the air through the sunbeam. So it's something that we all need to be aware of. So now these are all the sources. So now we can start talking about the filtration process. At this point in time, does anybody have any questions with regard to the VOCs, the sources of these allergens, or anything like that? All right, I will carry on then. So again, the best possible thing that you can do is remove the source, if that's possible. If you can remove the source, then you've eliminated the problem. But in general, that usually ends up not being a practical thing. You're not going to remove the walls from your home to get rid of paint and coatings, VOCs. You just can't do that. It's not practical. Now, you can use the lowest VOC type of paint possible, and that will help eliminate or reduce the amount of materials you have, but there's really no way to remove it all sometimes. When this isn't possible, then the next best thing would be to improve ventilation and add some fresh outdoor air. That's not always practical either. It may be very cold in your region, or it may be very dirty air in your region, and you don't want to bring in fresh air from outside. But that is a good way to help at least mix up the VOCs in your home with fresh air and dilute the effect of those VOCs on you or the occupants of that home. When this isn't possible, that's when we start turning to looking at filtration and air cleansing. Okay? So what we look at are, in this particular portion of the talk, are filtration types. What type of filter could be appropriate for different particle sizes? How can you filter VOCs? And finally, what other types of air cleansing technology are available? So when we improve indoor air quality, again, I just mentioned the source removal, reduction, ventilation improvements. But then we're going to talk about the air cleaners and air cleansing. So air cleaners can be installed in the HVAC for whole house conditioning, which can run into the anywhere from $2,000 to $10,000 range or higher, depending on the size of the home or business. And in general, this talk is more for home ventilation, because commercial ventilation has a whole different concept that uses similar principles. And then air cleaners can be also portable room air cleaners. And I recommend portable air room cleaners a lot for people, especially when they're in their bedrooms 8 hours a night, and that's where their problem occurs. Look, put in a room air cleaner that can help to reduce the VOCs that are present, or allergens, or whatever it is that's causing the problems for that individual. So regarding air cleaners, they have primary and secondary impact. And what I mean by this is that the primary is that you are potentially reducing the contaminant concentration, okay? But secondarily, what a lot of people don't realize is that you're also using a lot of energy in the process. So as far as the overall energy level, the energy use, and how are we affecting our environment? You're improving your condition on the inside, but you're also using more energy. Then you also have possible byproduct production from the air filter, air cleaner that you're using, and that is what I'll discuss later. But that's just something to keep in mind. Another thing, there's a common misconception that you will always improve your air quality using an air cleaner. And that would be the case if, especially when you first put a filter in, you're typically improving your air. But it turns out that if you let the filter get clogged up and you allow that to continue to run, then you're going to reduce airflow. You're also going to reduce the turnover of VOCs in your home, or the turnover of fresh air in your home, and you're going to impact your indoor air in a negative way. So you have to be careful about thinking that an air cleaner is automatically going to help. It sometimes, depending on how you handle it, could be a deterrent. And depending on an air cleaner that you use, VOCs may not be removed, because some of the basics that we see in the stores don't remove VOCs. And then from the ones that we do use that do remove VOCs, we have to be careful about the secondary byproducts that are potentially returned into the air from the cleansing technology. And by the way, just so you know, in preparing this talk, I did not use any jargon from any vendor. I did not use any names of any vendor, as far as I can tell. And I've tried to be very objective about what I'm discussing here with regard to that. So I'm not really making negative statements about any one individual. I'm just saying these are some of the potential pitfalls or the advantages and disadvantages of a particular type of air filter or technology, just so you're aware. Just trying to keep it as scientifically objective as possible. So there are two types of air cleaners that can remove particulate matter, but these do not deal with VOCs. But these are a lot of what we have in homes right now, are mechanical air filters, such as HEPA. HEPA stands for High Efficiency Particulate Arrestants. So you're trying to arrest particulates from your home air. These are limited by particle size, and we'll see that information a little bit later. But electronic air cleaners, such as electrostatic precipitators, they sort of charge the air, so the particulates are charged, and then they get captured by an electrostatic filter, or they essentially fall onto a surface and get removed from the air. When they remove from the air by falling onto a surface, then you need to make sure that you're not mixing that dust up by walking through with air movement. So trapped particles using electrostatic attraction, or they produce ions which attach to airborne particles, which makes them fall out and settle faster. But neither of these types of air cleaners can remove VOCs, which have much smaller molecular sizes. So we're going to talk a little bit about that here in a minute. So these are some typical air filters that you could see. They're the ones that most people put into their furnaces are called media air filters. And then I'm going to talk a little bit about each of these types of characteristics. This is hard to see, so don't worry about reading in between. But this is a particle size chart. And the main thing is that these are large particles over here of about 5,000 microns, which would be a raindrop almost, that size. That's what the first one is. And then we have sand tailings, mist, ground limestone, pollens, and these are all in the range from 1 to 50 to 500 microns. And then you get down here into where you can't see it with the visible eye anymore, which includes bacteria, smaller dusts and fumes, paint pigments, coal smoke, resin smoke, tobacco smoke. We can't see those, but they're there. And then carbon black is down here. And I'll show you later where a VOC falls into this range, way down below that chart. So this is a particle size chart. And then we look at what's known as the MERV index for an air cleaner. And the MERV index is a rating of how well it performs with removing particulate. So it stands for minimum efficiency rating value. And the higher the MERV rating is, which goes up to a number of 20, the better the effectiveness of the air filter is, and the greater the number of dollars you spend on it. So most indoor air quality for homes is 13 or below, but the ones that are 20 are for clean rooms and hospitals and laboratories where they need to have a clean room, and you wouldn't use those for your home anyway, but that's what that is. They will arrest contaminants less than 0.3 micron in particle size. Now remember that when you think about particulate matter, we talked about being less than 2.5 is respirable and goes into your lungs. So the better you can get rid of those 2.5 micron and below, the better off your home is, and the better off your filter is, depending on what you're willing to spend on that kind of thing. And then, so this is from the range 20 down to 9. When you get into the range of 16, you're talking about 0.3 to 1 micron particle size. And then 12 is 1 to 3 particle PM particle size. And then it goes all the way down to 1. And this is using carpet fibers, which, it's not very effective at all at air. So the ones that are most commonly used in homes are from 6 to 13. And these, you can see the superior ones for residential homes are about 13 MERV rating. And these are pleated filters. They do not capture VOCs, but they're very effective in the particle size of 1 to 3 PM. So they do capture part of that respirable PM that we talked about being dangerous to your lungs, but anything below 1 micron, it's not going to capture. So the cost, I looked up some costs, and I actually just looked this up today from nationwide building product stores, such as Home Depot, Lowe's, etc. And the allergen reduction furnace filters, which are the higher rated ones for homes, they have a MERV rating of 12. They're electrostatic, and I'll explain electrostatic in a few minutes. And they have a 3-month lifetime, and they range in price from $25 to $40 a piece. So they're on the expensive end for these types of filters. And then the basic pleated MERV rating of 5, $4 and up. And that's pretty much what's in my furnace at home, I hate to say. So anyway, these are just the common filter types. And there are different methods for filtration. You would think that the only thing that happens in a filter is that the particulate matter comes in and gets intercepted by where it can't get through the fiber, but that's not always the case. So straining occurs for particles that are larger than the distance between fibers, and this is what we normally think of when we think about air filters. And there's no choice but to be stopped. And that looks like this. Here's the air flowing in. Here are 2 fibers. The particle's larger than the distance between the 2 fibers, and it gets stopped. Well, if you have this happen often enough, you're going to clog up your filter eventually. So that's why you need to change your filters. And that looks like this when you're doing the straining. It just like stops. It's there. And then with interception, it runs right into the fiber, and the picture up here shows going around the fiber, and it just like kind of collides with it and hangs onto it. A lot of times that hanging onto it is due to maybe an electrostatic attraction between the particle and the fiber as well. And then we have inertial impaction, which just runs straight into a fiber, and that's it. Or because it's so heavy, as it's trying to go around the fiber, it just runs right into it. So that's the inertial impaction. And then finally, there's diffusion, which occurs from usually smaller molecules that kind of goes around and then hits a particle or fiber and sticks to it. So this is a summary of those: sieving, interception, inertial impaction, and diffusion. And then there's one more, and that's the electrostatic attraction. That's when the particle is either charged or the fiber is charged, and the particle is intercepted. My particle disappeared. What happened to my particle? There it is. And it gets stopped by electrostatic attraction. So those are the mechanisms for normal filtration. And usually for anything greater than 0.2 microns or bigger, the impaction and interception are the prevalent mechanisms. But below that, you have diffusion as dominant. But in the process of that diffusion, many of the particles pass through, and the filter is ineffective at capturing them. And so in general, this would be an example then of a single stage that we're talking about, these single stage where it's just a filter. So the dirty air is coming in on the left-hand side, coming through this pre-filter, which is normally disposable, and then you go through a fabric filter cover, which is disposable, and then it goes through the HEPA filter, and only a few of the air particles, of the air molecules come through, and the HEPA filters themselves get clogged over time and then have to be replaced. But that would be a HEPA filter that's only taking care of particulate matter for the most part. And then we have, my clicker, sorry, air filter with electrostatic filter. So the way this works is that the unfiltered air is passed through a pre-filter right here, and that pre-filter you can remove like you would any other. It's like capturing the big stuff first. And then there's an ionization section here where it positively charges the particles. Those positively charged particles are then captured on these collector plates, and the collector plates have to be cleaned frequently to make this work effectively. But as the collector plates are being filled up, then when they pass through the final filter, you have clean air coming out the other end. And these are all still considered to be single-phase type filters where it's only dealing with particulate matter. This particular one could, with charging, can help deal with allergens and bacterial materials because it will help to remove those from the environment. But what about VOC and formaldehyde removal? What do we do about that? And so with VOCs and formaldehyde, the gaseous pollutants require that some kind of absorbent material be present. So whether it be activated carbon, I've got a few examples, but activated carbon or some other material, adsorbent, has to be present for this to work. It's difficult to compare the different adsorbents because the guidelines don't yet exist for these types of VOCs. Although the ASHRAE Committee 145, they're developing guidelines for HVAC installed systems, but not for room cleaners yet. So they're working on that. So the one-stage method of filtration we talked about was, I've already talked about particulate matter, but now for two-stage, you want both your first stage, and then you'd like to have the activated carbon filter or some kind of adsorbent material to remove particulate matter plus some VOC remediation. So it comes down to understanding how that VOC remediation works. So in the enhanced two-stage, that's a little bit another slide later. So that's one way of dealing with VOCs. And then what about airborne viruses, bacteria, and molds? How can you remove those? And that's going to be the enhanced two-stage, which includes everything we've already talked about, plus some kind of cleansing technology, whether it be electrostatic, UV, ultraviolet, ionization, photocatalytic oxidation, which is also known as PCO, ozone, and cold plasma. Those types of technologies currently exist for helping to remove VOCs, bacteria, molds, etc. So these are different air cleaner types, and I just highlighted the media filtration is what we've already talked about. And then we're right now talking about adsorbents, which involve organic and inorganic gas phase contaminants. And then the photocatalytic and electronic air cleaners and ozone we'll talk about a little bit later. But the thing to keep in mind is that all of these different types of air cleaners are currently available on the market. And I always say that, just make sure that everybody understands what it is you're buying. before you buy it, and understand what the potential advantages and disadvantages and the pitfalls are for these. So with single-stage filters, we talked about the fact that we cannot capture VOCs, and so now that's why we're talking about VOC adsorbents. But I put up one more particulate size. Here's 1,000 up here, and here's 0.01 for some of our particulate matter. And formaldehyde has a diameter that's 100 times less than the smallest particle that we were talking about on that scale. So formaldehyde has a diameter of 0.0001 micrometer, and that's the smallest organic molecule that we know. And so then there are VOCs in the range from 0.0001 up through probably 0.01 as far as what we capture on VOCs. So VOCs typically are too small in diameter to be trapped. They don't get trapped by electrostatic attraction. They need to have an adsorbent present for that to work. But again, remember, the best thing is source reduction and source removal. If you understand what the source is, if there's a gas can in the garage, you build a shed outside and you get rid of the gas can from the garage and you just remove the source from your indoor air. This is if you can't remove it and you want to help your indoor air quality and you're trying to improve the indoor air quality for people that you are dealing with in your home inspections. That's why you would use a carbon adsorbent filter for that. Yes, can you please? Thanks.
Would a air-to-air exchanger work for VOCs on a quite effective way?
If you don't mind, can you explain to me what an air-to-air exchange that you're talking about?
They make units that simultaneously bring in fresh air from outside and exhaust air to the out.
Yes.
And they're simultaneously coming in, and they go through a heat exchanger.
Yes.
To make them more energy efficient, so you're not losing your air-conditioned or heated air.
Yes, that would definitely help.
And you can set them on timers and run them 24 hours a day. You can run them, for 2 hours. I personally have one in my own house because I have a very, very energy efficient home.
Good.
And mine runs for 3 hours in the morning and then runs for 3 hours in the evening.
Okay.
So. Yeah,
that's very nice. Thank you. I appreciate you sharing that because that goes in line with the addition of fresh air into the equation for reducing VOCs in your home, and I think that's why it's so effective, is because you're bringing in fresh air and you're diluting the VOCs that are present. So if you add that along with the first stage of filtration, and you add in your carbon adsorbent, that makes it even better, I think, in general. But if you don't have a VOC situation in your home anyway, you don't necessarily have to have a carbon bed adsorbent. It's mainly for people who are experiencing maybe some chemical sensitivities even that may want to start, they worry about their indoor air quality and might want to start using it. So thank you for that contribution. Sorry, this thing is like moving on me a lot. So for VOC removal effectiveness, when you're sending air through, if it's screaming through your filter too fast, then you're not going to effectively remove anything. So it depends on airflow rate, velocity through the adsorbent, the concentration of the contaminants. If you have too high of a concentration, you're going to essentially use up the carbon bed adsorbent. These carbon bed adsorbents, that's a fairly thin layer, but some of these have been known to have as much as 600 meters per gram of surface space. Think about 600 cubic meters of surface space, because you're essentially capturing through all the little pores of the carbon, et cetera. So there's all this space available for adsorption. You just need to make sure that you're not letting it go too long or that you have too high of a concentration of VOCs for it to be saturated immediately. And then you have to continually fix things. So that's why sometimes carbon bed adsorbents they're nice, but if you can't remove the source, then you're just going to keep on replacing things to try to keep your air fresh on the inside. It's also depends on the total available surface of the adsorbent and then the temperature and relative humidity of the gas stream. The higher the temperature, you're going to increase, anytime you increase the temperature in your home, you're going to increase off-gassing of VOCs from surfaces that are within the house. Higher humidity will sometimes help saturate the carbon bed adsorbent and also elevates the levels of formaldehyde in your home because formaldehyde likes to interact with water and be carried through the home on the water. So usually people use an activated carbon adsorbent, and it is effective at removing formaldehyde. We had a case study where there was a 3-month use of a simple air filter with a carbon bed adsorbent in it in the home for 3 months, and their formaldehyde level reduced from 120 nanograms per liter to 43 nanograms per liter. And they didn't really do a lot of, they were careful about what they had in their home, and they may have done some remediation based on some recommendations that were made. But in general, the air filter actually ended up working better than the remediation efforts they made. So the VOC removal mechanism either depends on adsorption, which is a physical process where the molecule is attracted to the carbon bed adsorbent, or it depends on a chemisorption, where there's a chemical reaction that occurs. Keeping it fairly simple, the adsorption is a physical attraction of the gas or vapor molecules to a surface. But because of the area of the carbon bed, it does have a limited capacity, and it requires frequent maintenance. So you need to, again, make sure that if you have recommended a carbon bed adsorbent or some kind of a filter to a homeowner, that they are making sure that they're keeping up with it and understand how to use it and how it works. And again, they work better at lower temperature and humidity because when you're at higher temperature, again, not only do the surfaces off-gas in the house, but the carbon bed adsorbent will start off-gassing when it's already collected. So if you collect at a certain temperature and all of a sudden it's 10 or 20 degrees higher, and that carbon bed is going to start degassing what came on it in the first place. That also happens if it gets saturated as well. Other types of materials that are used include silica gel, activated alumina, zeolites, synthetic polymers, porous clay minerals. So if you see any of these words in a air filter, that's generally consistent with that. Yes, do you mind? I'm sorry.
The porous clay, is that the same thing as cat litter?
Yes, porous clay can be the same thing as cat litter. The question was the porous clay the same as cat litter, in case that wasn't heard. But yeah, that's what that is. And so it's effective. You can now buy a cat litter that says it helps remove odors. And that's part of that, is it's absorbing into the particles as long as you're keeping up with the cat litter. Obviously, if you let it go a couple days, it's going to be ineffective. It's no different than any other filter. And then there's chemisorption. That's where the VOC reacts with the absorbent material. And in general, this deals with binding of when it binds to the absorbent, it's forming some kind of a salt, usually. But sometimes that final product is broken down further and released back to the atmosphere as carbon dioxide and water, so that's effective. It's not dangerous to the people present. And this is a little bit more technical, but one of the chemicals that's used in aluminum oxide is potassium permanganate, and that's even more effective than carbon beds at removing formaldehyde and sulfur dioxide and nitrogen dioxide and those kind of things, but it's not very effective at removing the rest of the VOCs. So a lot of people only use that on a limited basis for removal of formaldehyde, for instance. You have to always make sure you maybe have some complementary filtration techniques occurring at the same time. And ask questions when you don't understand. I mean, not here, but I mean like in general, moving forward. I'm always available for a phone call if you have a question about any of this type of thing. And then you have the pollutant destruction filters. This is the third stage that we were talking about. You have the VOC carbon removal, but you also have the potential for the pollutant destruction. And that's where we have deactivation or destruction of pollutants. And this could be either a UV germicidal irradiation cleaner that uses UV light, and I'll discuss some of the pros and cons of that. And then photocatalytic oxidation, should say PCO, I apologize, that's a misprint, PCO cleaners, and then ozone generators. What is UV light? Well, in general, when we think about light coming from the sun, we see essentially white light, which is a combination of all visible colors. But what we see is just a small component of actual light in general. Right now, we have lights coming to us to each one of our cell phones to tell us whether or not we have messages or not. So every cell phone has a different frequency. Every different old TV station that still pushes out, radio waves and television waves. In any radio station right now, we are receiving that light. So light is all around us. And the stronger the light, though, the more energetic it is. When you think of the visible spectrum in the middle here, you have violet all the way up through red and orange. These lights at the end are the infrared, and these are the lights that you see that are being used to keep your food warm while it's waiting for other food to be ready. So those are your heat lamps. We have heat lamps in the garage to keep our rabbits warm. And then you have the ultraviolet light, which is UVA, UVB, UVC. And once you get, so ultra means really, really violet. And so you're down at the violet end, and there's UV. You do see like the violet light when you go to like a barber shop or a salon, and you see the combs being stored in a vessel that has that light, and that's killing the bacteria that could be present on the combs that were just used in your head or whoever else's head. So this is UV light. So it is electromagnetic radiation, comes from sunlight, and in fact, the UVC, which is very destructive to us, is filtered out of the environment by the ozone layer. Ozone is bad down, it's good high. And so the good high is sometimes, that's why we've gotten rid of some of our chlorofluorocarbons, because they were impacting the upper ozone layer. So anyway, but we can use UV indoors in a controlled setting to try to help remediate VOCs that are present, or aerosols or biologicals. So UVA is black light. Those are the lights that you put in and it makes your white clothes glow. Suntan booths use UVB, and then UVC is the ultraviolet germicidal irradiation. And so the UVC is typically what's used in air cleaners to try to help remove VOCs from the air, these different contaminants from the air. UV light benefits, it helps to limit mold and bacterial growth in the area in which it's being used. I emphasize that, in the area in which it's being used. It limits growth on HVAC coils, and I'll show you that in a minute. A very dramatic picture on that. And it reduces maintenance costs due to the fact that you're not having to deal with the coils being dirty, and it also reduces that dirty sock syndrome from the air conditioning coils. And then it reduces airborne contaminants. Those are some of the benefits. Now, I say it reduces airborne contaminants with some caution, because some of the pitfalls are that it's not always very effective because of the amount of time that the contaminant spends with the UV light. That's very important. So this is an example of a multi-stage air filter that uses all three. So the air comes in, it goes through a pre-filter and the charcoal layer, which helps to remove the VOCs, and the true HEPA filter, which helps remove the particulates. And then there's a UVC light, and in this one in particular, it has a catalyst, which I'll discuss a little bit later. But the UV light helps to remove the airborne germs and decomposes some of the remaining molecules. So this would be a room unit, which would run up to about $500 to $600 or more, depending on where you would get it from. I noticed today when I was looking that these air cleaner for rooms, the prices are all over the place. I mean, they range from $90 up through $1,000, depending on the model that you buy, the reputation of the manufacturer that you're buying from. So I really couldn't put together a good comparison cost list. The best thing, if you are recommending something like this to somebody else, is to do a search on Google, for instance, to see if you can recommend to them a supplier or a manufacturer that looks like they would be a good fit for that individual. So this is the coil of the air conditioner without UV and with UV over here on the right-hand side. And this is after continuous use. So the air passes through the UV light and comes out through here, and it's clean still. This picture came courtesy of Greg Jutras, who is with the HVAC Corporation. It helped. He gave a talk in Chicago in June, very good talk, and he shared some of his information with me. UV light then, the big thing about UV light, it helps to kill RNA and DNA, which it would be bad for us, obviously, but it's good for killing the RNA and DNA and bacterial growth. But it does not travel well. It's an inverse square law, but the key thing here is that UV energy times time equals kill. So if you don't have enough time for the kill, it's not going to work effectively. So if you have too high of an air movement, or if the air is going around the UV light without actually almost being in intimate contact with that UV light, it's not going to work effectively. And so it does not travel well. And you can see here's the UV light here, and you have 100% power 1 inch from the source, but only 25% power 2 inches from the source, and it goes worse than that as you go out. So you have to make sure that the airflow is able to make intimate contact with that UV light to be able to have it work and then not be moving too fast. So whereas we said earlier that it was good at removing, that's only if you can actually maintain the time for it to do that. So it does have sometimes limited effectiveness in destroying airborne viruses and bacteria, mainly due to that amount of time exposure to the UV light. So it's a kind of a pro and con at the same time. It will help, but it doesn't necessarily remove everything. And it should be used with, but not in replacement of, other filtration devices. So you definitely want to make sure it's part of a system, not the only system. And then some mold and bacterial spores still require higher UV dosages and exposures, which would go down to that 180, I think it was called the oxidizing spectrum of the UV light. And then we have photocatalytic oxidation. Photocatalytic oxidation is prevalent in some new air systems in the past 5 years or so. And what you have is you have a UV lamp, and then you have a photocatalyst, which is known as titanium dioxide. That's used all the time. So the photocatalyst absorbs the UV light and forms strong oxidizing hydroxyl radicals that have this formula OH it's a radical formula. What these radical hydroxyls do is they attack bacteria and pollutants and essentially then help destroy them by releasing carbon dioxide and water out the other end. Again, what can possibly happen, though, is sometimes it doesn't go through all the way to completion, the reaction, and so you end up maybe possibly getting some other VOCs that are in the effluent of the filter that could cause some problems to the indoor occupants. Again, it's just a matter of it could happen, and there are some things that don't work very well with this. But again, it's combining UV light with a titanium oxide coated filter, and then these radicals are generated, and they're highly reactive to the bacteria, VOCs that are present as well. They're designed to destroy gaseous pollutants by changing them into harmless products. But these also, again, they're designed to remove particulates, but the limitation is that they're ineffective at destroying gaseous pollutants in indoor air. So they'll do well on some of the larger particles that they have time to interact with, but they're not always foolproof in being able to get the VOCs as well. Some PCO units fail to destroy altogether, and they produce new indoor pollutants that could cause irritation of the eyes, throat, and nose. Example, formaldehyde formation, because it didn't go all the way down to CO2 plus water. So formaldehyde could come out as a side product. And we have had issues with where people have called in and said, "Hey, I just did some kind of a treatment in the home, and we're getting high readings on formaldehyde." And usually formaldehyde can be one of those VOCs that's due to incomplete combination of whatever is happening. Also, you can get some HCl gas from chlorides that go through this. And when HCl gas gets into your lungs, it turns into hydrochloric acid, which is irritant to your lungs as well. Typically, it's not at a really high level, but it still could impact the people who are in the home. And then there are the air cleaners with ozone generation. The FDA requires that these types of units be limited to less than 50 parts per billion of ozone as they're being formed. So you can't put more into the room than that, because ozone is very destructive to lung tissue, etc. Ozone is also very destructive to anything that has a double bond in it, chemically speaking. So anything that's like a rubber gasket or any kind of materials of construction like paint on the walls can be impacted by ozone. And I'll talk about that a little bit later. But ozone is formed by either UV light or corona discharge to form 50 parts per billion or so of ozone, which goes out into the air, and then that ozone is supposed to be reacting with bacterial particulate matter in the environment that can then destroy it as it's reacting with it. But at these levels of 50 ppb, it's not a real effective cross-section of the reaction. You need a lot more ozone to interact with the particulate or the biological materials than is present from these machines to help remove it all. It's just not real effective at doing it. But it can help. And again, you just have to use it with caution on who's present in the home. If they're chemically sensitive, are you causing more problems than you're creating, or than you're trying to fix by the use of these machines? Finally, there's another one known as a cold plasma treatment. And this is where you use the needle point ionization to break down gases with electron volt potential numbers below 12. So it uses an ionizer, and if it's an oxygenated material, typically those have values below 12 for the gases. Hydrocarbons sometimes are higher than that, so you're not going to remove things like gasoline vapors, but you can remove oxygenated materials from the environment. And these are attracted to airborne particles, and they're effectively removed by particulate filtration. Then tests are ongoing on all these types of vessels, though. You can do a search on any of these types of filtration devices, and you can find out. You'll get the one set of information from the manufacturer of it, indicating all the good points, which that's understandable. But then you also will have scientific studies that are done to try to help give the overall picture of whether or not it's good or not for that particular application. So this kind of puts it all together, though. You have a pre-filter, this type of filter, a HEPA filter to help remove particulate matter, activated carbon filter to help remove VOCs, and then you have a photocatalytic filter, which will hopefully help remove some of the airborne allergens, a germicidal UV lamp for the same thing, a negative ion generator, and then ozone is optional. So that's a fairly expensive looking device, if you ask me, but it kind of combines everything, and hopefully at the very end, with that kind of a device, nothing new has been added to the environment from it. And this is pretty much the same kind of a thing, multi-stage air filter, which goes through pretty much the same process I just talked about. So in comparison, though, for small room units, again, I couldn't find a set price. They were anywhere from $90 on up with regard to finding good HEPA filters or filtration devices. But some of the room units, though, are up to $500 when they have the photocatalytic oxidation in them or whatever. And some of them, I couldn't find anything that was up to $1,000, but I think they do exist, so I couldn't find anything when I was searching. But most are available at building supply stores. The last thing I want to talk about, but on the conclusion about these destruction filters, is buyer beware regarding potential hazards of use. Again, scientific evidence suggests that secondary products exist that can repollute indoor air, so you always have to be careful about what it is that you're trying to take care of in the situation that you're in. Know what you're buying and ask questions. The last thing I want to talk about, just a couple slides here. I know some people like to use ozonation to help remediate tobacco smoke check or some kind of a pollutant. And I think that, in general, it has its points where it can be a good application. The thing that you need to really be aware of, though, is the secondary destruction that occurs with the use of an ozone machine. Typically, you're introducing 35 milligrams per hour of ozone into a room, and some units go higher. Some people leave them in there for an entire day. Just remember that you're going to chew up the walls that are there. Any kind of rubber or plastic material that's susceptible to ozone, to reaction from ozone, will be affected. And then you create formaldehyde, and you create secondary products like aldehydes in the process of doing this. Again, there might be some applications where it's really critical to remove something, and it might be useful for that, but I always caution people about the secondary byproducts and the fact that formaldehyde will be formed from that process. And then there's a newer thing called chlorine dioxide, which supposedly is less effective, less reactive than ozone or chlorine, and it helps to remove odors and microbials. And there's also, I think, a hydrogen peroxide type treatment for especially industrial applications where you're involving like food applications. I don't have a lot of information on chlorine dioxide. It doesn't form as severe secondary reaction products as ozone, but I'm not exactly sure how it would affect the indoor occupants from the after application of it. So keep in mind that other environmental factors can be controlled when you're doing work for people. You know, the higher the temperature, the more VOCs they're going to get from off-gassing, so they want to maintain a good temperature in their home. Humidity, the higher the humidity, if you have a dehumidifier, that would be great. That's a good addition to a home to help reduce the levels of formaldehyde in your home, especially with both temperature and humidity. And then the airflow. The higher the airflow through, the more you're diluting the VOCs in the environment of that home. And for exposure limits, there aren't any exposure limits for residential. A lot of states, though, are, they're looking at recommendations from California for some of the chronic reference exposure levels for VOCs. And now with the new LEED version 4.0, where if you're trying to get LEED certified, you now have to be compliant in 31 different VOCs along with the TVOC. They also have a pilot credit where it does not rely on VOC. And our company is now set up to help people with LEED version 4.0. So I'll come back to this in just a second, but I wanted to mention that there are useful online resources. We use the National Institute of Occupational Safety and Health very extensively for the household product database. You can put a product name in or a chemical abstract number, and it will tell you what kind of VOCs are present and at what percentages for certain compounds that are present. I'd like to thank Alice D'Elia, my lab manager at PRISM, and Les Kepper, President and CEO at PRISM, for the opportunity to be here to talk to you. Greg Jutras, again, was very good on discussions with me in June regarding all of this information, and I can be contacted at this number. And especially if you can't find the updated slides, I'll gladly get you a copy. And in closing, I just want to see if anybody had any discussion on any case studies they had. We can bring that up, or if there are any other questions. But I do appreciate your attention and your attendance today, so thank you.
Dr. Steve, would you mind expounding a little bit on a VOC problem that most people don't seem to have an understanding for, and that's the toxic amount of VOCs that come off from drying clothes?
Drying clothes. For dry cleaners?
No, we're talking about where you using all of the laundry detergents,
yes,
the softeners, and people that have backups on because your lack of ventilation that is being exhausted out because they don't clean their dryer vents.
Right.
Now it comes into the
yes,
of the home.
And thank you for that question. The one thing that there's a professor at the University of Washington who's done a lot of work studying laundry detergents, VOCs from the dry cleaner. I mean, not the dry cleaner, but the dryer sheets that you can put into the dryer. And the one thing that comes up all the time is that the government does not require declaration of what kind of VOCs are present in the products unless they are a hazard. And so what happens is a lot of us are actually susceptible to terpenes, which are in the environment, which are in these detergents or in the dry cleaner or in the drying sheets. And so these VOCs that are limonene, alpha-pinene, beta-pinene, these are all odorants that help us, they smell good. But they're in plugins that are in the wall, they're in these laundry facilities, and they are in your indoor air then as odorants. And they affect people asthmatically. I mean, they're not good. Is this what you're referring to?
Absolutely.
Okay.
We've had people that I've done studies on that end up with immune problems because of the concentration of the fabric colors, any of our products that we add in there for physically cleaning the clothes. And when you don't exhaust out, you got to build up a plant. It's back flowing back through the house. And it ends up compromising their some people.
Yeah, and related to this is the fact that they're starting to outlaw the use of plug-in air fresheners in schools because children are even more susceptible to these VOCs than others. And so if you're in your area and you hear about school issues, ask them if they have plugins. They need to get rid of them. Yes, sir. And thank you for the question, Shannon.
Thank you for your presentation. It was excellent. When you see the picture of the Earth from outer space, or they do diagrams of it, is the ozone growing or getting less and less?
The ozone layer itself is stable, mainly because of the fact that we've reduced the number of chlorofluorocarbons, and now we're using hydrochlorofluorocarbons. That's not as good for us as people who want to use good refrigerants, because the old CFCs were great for refrigerants. But now we're using HCFCs, which don't break down as much into these radical compounds, which then go and interact with the ozone. What was happening, in the ozone layer, there's a process called the Chapman cycle. Just in general, what happens is there's the sunlight breaks down oxygen, creates ozone, and in the process goes back, creates more oxygen, and keeps the ozone there. It's like a cycle. And when those chlorofluorocarbons were going up to the upper atmosphere, every time that cycle was occurring, the brominated chlorine would say, nope, I want this ozone right now, and so it takes it out of the picture. And then you have this hole developed. And what happened in the Antarctica was that it would be dark for 3 months. Well, all these brominated compounds were essentially concentrating in the atmosphere, and as soon as the sunlight hit them in the spring, all these chlorofluorocarbon radicals interacted with the ozone and created the ozone hole. And so that's what has been happening. From what I understand, we're more stable now because of the fact that we got rid of the CFCs, part of the Montreal Protocol of 1970.
That was my next question. Why do you always see the holes at the north or south poles? You answered it.
Okay, thanks.
Here from Prism, I just wanted to bring up a little bit of extra on what Shannon was saying about the dry cleaning. Or not dry cleaning, but the dryer in general. Remember in Steve's presentation that heat and humidity increase the VOCs. So now we have heat and humidity as we put wet clothes into a dryer, superheat them to dry them, that if it is backing up, that can be a very large source, like Shannon says, of VOCs in a home. I know in my home with kids, we're drying once a day a load of laundry. The other thing that we've done some white papers on in the past, as far as some of the chemists, is the treatments that we get on our fabrics. Not just the colors and fabric pieces themselves, but the treatments for stain resistance or what's that called? Wrinkle release, those types of things.
Yeah, the sizing.
Stick in there for quite some time, so you have to be careful when purchasing some of those. Proper ventilation of the dryer is very key. That's a quick and easy way to reduce VOC levels in the home.
Yeah. Thank you, Sarah. The other thing to mention is that, tetrachloroethylene supposedly was banned from dry cleaning many, many years ago, but for some reason tetrachloroethylene still keeps showing up in indoor air quality results. I'm not quite sure why, because people do dry cleaning. That's what we end up seeing is the tetrachloroethylene. Do you have a comment on that, Shannon? Oh, you can come up. I'm sorry. That's fine. Since I brought it up, and I'm sorry. I'll get your question next.
A number of our clients that I've done studies with, especially like airline personnel, they get everything dry cleaned. They forget to take it out of the bag. Mm-hmm. They bring it in their homes. And it sits there for weeks and weeks and weeks. So consequently, they're exposed to this. And this definitely affects, I've had several, I do a lot of indoor air quality stuff. And like I said, it's 60% of my business now. So we find that people don't clean their vents, are the ones that are basically what? Vertical, or they go up into the attic area and then they go 20-something feet out. As soon as you start getting the dew point changing within that, now we get the buildup. So any of your clients that you're going out there working with, please make sure that that's one of the first things you check. Are they getting this kind of exposure because of the back pressure dumping the VOCs back in the room? I've had, probably in the last 3 or 4 years, I've had several that had their immune systems completely destroyed. And one was which they had the back up there, and the other two where they thought that they were humidifying their house in the wintertime, and they put pantyhose over to collect the lint. So they were adding the humidity, but all of the VOCs that were and they had the symptoms of lupus, and they became so sensitized. One I recommended to move to the Florida Keys. The other one actually ended up moving to St. George Island. So, but they got relief once they had the fresh air, the exchanges, and so forth.
Thanks, Jen. Yes, sir.
Thank you for the presentation.
You're welcome.
I guess in terms of testing for this, I don't know if this is outside the scope, but for particular matter or VOCs, what would you recommend in terms of how would you test for that? And just if you can comment on that.
Well, for VOCs, I'll say that there are canisters available where it's like evacuated, and you essentially release the vacuum, and over time it fills the canister, and then you send that in for analysis. But then I'll mention that what we use at Prism Analytical are thermal desorption tubes, which are more convenient, we think, to send in the mail. And we do formaldehyde and VOCs with these thermal desorption tubes. And it's a 2-hour test, and you essentially get an 11 to 12-page report back indicating contamination index, what types of VOCs are present. I showed all those different areas of where you could get VOCs from. We give contamination indexes for all those. And then we give you a formaldehyde number based on, and it's not something where you have to keep it cold to get it back to us. And then with particulate matter, you would need to take some kind of a surface analysis, whether it be people use aerosols for molds. Other people like to just take a tape lift and over a surface and send that into, like we use Environmental Analysis Associates, Dan Baxter, for our work, and we highly recommend him. He's a scientist and surface scientist, but that kind of a thing. So, in general, you need to get complementary information if it's something where you feel like it's all-inclusive. Indoor air quality is all-inclusive. Many times, though, some of the VOCs can cause more problems than others, and in other cases, allergens and bacterial growth cause more problems than VOCs. So it's you get an indoor air quality test back showing that the VOCs are green, but the occupants are they're miserable, and that's because of other issues that aren't showing up on a VOC report.
Okay. Thank you.
You're welcome. Anybody else? Well, again, I appreciate your attention and your attendance. Like I said, it was a new experience for me to be able to talk to you about this. So I appreciate your patience with my understanding of the situation as well. So I hope you gathered something from this, and that you would feel free in the future to give me a call at Prism to talk about it if you have questions about it. So.